Hello, welcome to the lecture 2 of Introduction to Information Security. In the previous lecture, we have already seen about what is information and its purpose, security and information security, and we have seen security goals, that is confidentiality, integrity, and availability, and we have also seen the RMIS model and what security goals have been included in that model. In this lecture, we will be concentrating on OSI Security Architecture with the security attacks, mechanisms, and services. And in video 3, I'll be discussing about the model for network security. So here, the concentration will be mainly on OSI Security Architecture. So let's begin that. OSI Security Architecture. This was recommended by the ITUT, which is the International Telecommunication Union. Telecommunication standardization sector, and it has been promoted to the recommendation which is mentioned in X800. If you want to know more about OSI security architecture, OSI is open system interconnections, and this term should not be new for you because you must have already studied about OSI network protocol model. This OSI security architecture was developed in context of the OSI protocol architecture. However, for this course, you need not have an understanding of OSI protocol architecture. OSI security architecture is independent of it. So if you do not know about it, no problem. Still, you would be able to understand OSI security architecture. This basically focuses on security attacks because the information about every aspect is already present. It is susceptible to the attacks. So security attacks have been identified in the OSI security architecture. Security mechanisms are those processes that are designed in order to prevent the security attacks, or if the attack has taken place, to detect it and recover from the security attacks. And I must tell you that security mechanisms, there is no foolproof absolute security mechanism because there is no specific way of doing an attack. The more secure the system is, the more loopholes are found out and new methods of attacks have been identified and applied. So it's an ever growing field and there is no absolute mechanism. And thirdly, we'll be talking about the security services. Security services means what kind of services do we need in order to enhance the security of the information that we are dealing with, while we are storing that information or we are transmitting that information, whatever. Now, security services, as we had seen the security goals, confidentiality, integrity, and availability, the thing is that these are the goals, but every time all the goals need not be achieved. For example, if you are issuing a public notice, so in that public notice, the services of confidentiality are not required because it is a public notice, so it should be openly available for everybody to look into it, right? So confidentiality as a service is not required in that particular scenario. In another scenario, if somebody issues a notice and says that your semester exam begins from tomorrow, now how will you identify whether it's a fake news or it's a true news? So you try to authenticate who is the originator of that particular message. So authentication as a service is required in certain cases. In order to get those services, there should be certain mechanisms in place. Once they are in place, the attacker or the hacker would like to still get the information and would try to attack. So ITUT has identified certain attacks, mechanisms, and services that we'll be discussing in the next few slides. But before proceeding ahead to the attacks, let's try to identify that what are the kinds of attacks. So it has been broadly classified into two kinds, that is passive attacks and active attacks. Passive attacks are mostly eavesdropping. Eavesdropping is like कान लगाकर सुनना. So it is more concerned with the getting the information, the confidential information. It is not at all about changing the information or modifying the information. It only intercepts the message. You are not modifying, you are not replaying, you are not inserting or deleting or duplicating, doing anything. You are simply listening to the message. Now, this can significantly harm the sender or the receiver. If you have seen the movie Imitation Game, you would realize that there was a machine called Enigma, which was used by the Germans, and later on, Alan Turing compromised that machine, and he was able to read the information, and he did not make it public. right? So what was he doing? Basically, whatever information the Germans used to send, they used to listen to that particular message and plan accordingly. So that is a kind of passive attack. These passive attacks are difficult to detect because the person is simply listening or overhearing the conversation, and while that is being done, you basically have no idea that the person is even listening to the messages. So they are very difficult to detect, but they could be prevented by placing certain security mechanisms in place. The best example is phone tapping, that two people are talking on the phone and the third person has tapped it and listening to all the conversations that are taking place. So passive attacks basically lead to the breach of the confidentiality. Okay, and the active attacks, when you are actually modifying, you are changing the information, you are replaying the information, you are duplicating the information, then these kind of attacks are called as active attacks, and they actually harm the system. They are easy to detect because the information being exchanged is modified. For example, if I tell you that we will be meeting at 10 a.m., right, and the message that you receive is that we will be meeting at 10 p.m. So there is a simple change of one character only from A to P, and that basically made you available in the evening and me available in the morning. So I'll be waiting for you in the morning and you'll be waiting for me in the evening. It is identifiable because at the end of the day we will be like, okay, I was waiting and you did not come, and you are like, okay, we were meeting in the evening and you did not come. So immediately we'll realize that in the transmission line there is some kind of a problem that has caused that change, right? So it's easy to detect, but as I said earlier, it's very difficult to prevent because the attacks have got no bounds. There will be attack however secure the system is, right? Active attacks are also those attacks that deny the services. For example, you are entitled to get certain kind of information or services, but you are not able to get it because the server was down, which has been deliberately made down by the hacker or the intruder, right? So such kind of attacks are called as active attacks, and they basically breach the integrity and availability security goals. Before moving ahead, let's discuss on the some of the abbreviations that we'll be using in the forthcoming text, and that is plain text. Plain text is basically the message that one person is trying to transmit to the other person, right? And the plain text would be represented by the alphabet P. Then ciphertext is represented by C, which means that the plain text has been converted into some non-intelligible form by applying certain mathematical formulas or based on certain machines that have been designed to specifically change the plain text into a non-intelligible or non-readable format, right? So that would be represented as C. Mathematically, if we talk about, then mathematically this C is represented by C equals to EKP, which means that the plain text has been encrypted by some encryption algorithm E and key, that is K. And when you want to get the plain text back from the ciphertext that you have calculated, then on ciphertext you apply decryption algorithm D with the same key that you have used over here. The same key is used and you get the plain text back. Now another key thing that you must know, that the keys are again of two types. One is your secret keys, and there would be, I would be referring them to be as KS, and then there are public and private keys. By the end of this course you would be able to identify both the things, but keys are of two kinds. You just have to keep that in mind. So this basically deals with the symmetric key crypto, and this is with asymmetric. All right. Security attacks. The first attack that we will be discussing is snooping. Snooping literally is defined as the action of secretively trying to find out something. So it is equal to saying that it's eavesdropping. Okay. So in this eavesdropping, you are trying to listen to the message. So there are two entities, Bob and Alice, and there is an entity that is the intruder or the hacker. So Bob and Alice are communicating and sharing certain kind of information among them, and that information is represented by the P. The intruder is listening the transmission line in order to get whatever information is being exchanged between Bob and Alice. So when this plain text has been sent to the Alice, intruder listens to the plain text, and since the intruder is simply listening it is getting the information. So the confidentiality has been breached and it is a passive attack. The solution to this problem is that you encrypt the plain text, and instead of sending the plain text you send the ciphertext. So second kind of attack is now traffic analysis, which is again the part of eavesdropping, that you are trying to listen the message. But as suggested in the previous slide, now when the Bob has to send a message to the Alice, then the Bob would be sending the C, that is the ciphertext. And while you are sending the ciphertext, the intruder would be listening to the transmission line and will be getting the ciphertext. This ciphertext is not intelligible because it has been derived after converting the plain text into some unintelligible format. So intruder would be like, okay, I'm not getting any information. This is all gibberish. This is not understandable. But still there is a flaw in this. The flaw is that intruder starts observing the pattern of the messages being exchanged, and based on that it can determine the location and the identity of the host. It can also determine the frequency and the length of the messages being exchanged, and based on such kind of information it may have an idea that what kind of a communication or transaction is being taking place. Is it a bank transaction that is being taking place, and what is the frequency of those transactions? So accordingly intruder may get certain ideas, right? This is called as traffic analysis, and in this also intruder is not making any change. It is simply getting the ciphertext and based on that doing certain tasks in order to get the information, right? So it is again a breach of confidentiality, and it's a passive attack. The next kind of attack that we'll be discussing is masquerading, and masquerading means that you are pretending to be somebody else. There could be two possible scenarios. Here I have changed the name of Alice to bank. Now let's imagine that Bob wants to communicate a message to the bank, or Bob wants to log into the bank for some transaction. But there is this intruder who has created a web page and he is pretending to be the bank. So instead of Bob being connected to the bank, Bob has now been connected to the intruder, thinking that intruder is the bank, right? So Bob will provide its confidential information to the intruder. In scenario 2, this intruder may contact the bank and then pretend to be Bob, because he has got the information of the Bob. So both the things can happen. Intruder can even act as a bank. It can sometimes act as the customer of the bank, right? And both the ways, it is doing some modification. It is replaying the message, the information that he has got from the Bob. Therefore, it is an active attack, and it is a threat to integrity, because integrity says that you cannot modify, replay the messages, right? Fourth kind of attack is replay attack. In replay attack, again there are three parties, Bob and bank. Suppose the scenario now is that intruder helped Bob in some job, and therefore Bob is now asking the bank to pay intruder a certain amount of money, and that message has been exchanged. This message has been passively heard or intercepted by the intruder, and he keeps that message, because what is the message? The message is that Bob is telling bank that please pay him 5,000 rupees, right? So if this message is captured by the intruder, it can help the intruder, because later on, once this transaction has taken place, at later point in time the intruder may send the same message again to the bank saying that please pay 5,000 rupees to the intruder, and in this way multiple transactions could be done. So this is called as replay attack. And please be mindful that I am telling you the examples in order to tell you the concept of replaying. Banking system is not so fragile that such kind of attacks can take place. So when you are replaying, it is like saying that okay, pay again, pay again, pay again, and the bank is paying again. There are mechanisms with the help of which you can avoid the replay attacks. It is also an active attack, and it is again a threat to integrity because it involves replaying of the old messages. Fifth attack is the modification, where you are actively modifying the content. And here the scenario is that Bob wanna tell Alice a message that don't stream the confidential proceeding, right? And this message before Bob could send to the Alice has been intercepted by the intruder, and that intruder is now sending the modified message that the live stream the confidential proceeding. So this is just the opposite of the actual statement that the Bob wants to communicate to the Alice, right? And therefore this is an active attack, and again it is a threat to integrity. Then the last kind of attack is the denial of service attack. In denial of service attack, there is Bob, there is an intruder, and you are getting some services from a server. Now what intruder does is, intruder disrupts the services offered by the server. And how can the intruder do it is with the help of the SYN flood attack. Now what is SYN flood attack? If you have studied the networks, then you must have studied about the SYN attack, because TCP protocol has got this handshaking protocol, and in the handshaking protocol you send the SYN message first and then you get the response from the server. So now this intruder deliberately is sending the messages continuously to the server, and what is happening now is that server is allocating certain resources to the intruder. Intruder has got a software that keeps on changing the IP address, so this intruder is sending so many SYN messages to the server that most of the resources of the server is occupied. So when a legitimate user is trying to access, he will not be given the access because the resources have already been occupied by the intruder. So this way, Bob, although he was entitled to get the services from the server, is denied the service. So this is the denial of services. Another scenario could be that the Bob is requesting something from the server is supposed to respond, but that response is not reaching the Bob. So Bob will not be getting the acknowledgements and the responses, and the Bob will be like, okay, I'm not getting the message, let me send it again. So now Bob starts sending the messages over and over again, and every time there is a reply, it just goes down and doesn't reach the Bob. This way also it is occupying the resources which might not give services to the other people who are eligible to get the services. And again, since the message is not reaching the Bob is entitled to get the services and Bob is not able to get them. So denial of service can take place in both the ways. The security services that have been defined by the ITUT X800 are authentication, access control, data confidentiality, data integrity, and non-repudiation. Authentication is basically of two types: entity authentication and data origin authentication. In entity authentication, the two parties that are communicating to each other, as we were having the Bob and Alice communicating to each other. So the Bob and Alice are the entities. It is now required that these two entities prove their identity. If Bob is sending certain message to the Alice should be sure that the messages are coming from the Bob. So in real time, Bob has to prove his or her identity. And in order to prove those identity, there are many mechanisms in place. For example, challenge and response mechanism that we'll be seeing later in the course. And this is required in order to avoid the masquerading and spoofing attacks, right? Because in masquerading and spoofing, what was happening? The intruder was pretending to be Bob and then sending the messages to the Alice. But now, when you are put up with a challenge to prove your identity, intruder won't be able to do it, and therefore Alice will immediately identify that the Alice is not getting the messages from the Bob, but it is the intruder who is masquerading and sending the messages to the Alice. In data origin authentication, we prove the source of the origination of the message. As I have told you in the previous example, if somebody issues a notice that your semester exam starts from tomorrow, will you believe on the notice? It could be a fake notice. How do you verify? You look for the stamp and the signature of the authority, if it is from the controller of examination or not, right? So in the logical scenario, the data origin authentication can be proved with the help of the digital signature. You have to authenticate that who originated the message. So that could be one of the authentication services that is required. The other one is access control, which tells you that which is the list of authorized people who can have an access to the information, and while accessing the information they may be asked for some proofs as well. So it basically could be achieved with the help of maintaining the access control list. Data confidentiality we have been talking about significantly now, which means preventing your information from getting leaked or from the passive attacks. This data confidentiality service encompasses not only the complete message, but sometimes some parts of the messages could also be taken care of, and the other parts could be left off because the confidentiality is not required for the complete message. And it is used in order to prevent the snooping and traffic analysis. Security services number 3 is your data integrity, and data integrity means that you need to protect your information from unauthorized modification, insertion, deletion, duplication, reordering, and replaying by any intruder or hacker or attacker or adversary. And this may also protect the whole message or part of the message. Non-repudiation. The repudiation means that denial of truth. Non-repudiation means that nobody can deny the truth. So if an event has occurred, there has to be a proof that the event has occurred. For example, if I give somebody 5,000 rupees, later on I ask that person that, okay, return my 5,000 rupees. The person may say that the transaction never happened. I never took 5,000 from you. So there has to be a proof to claim that the person has received 5,000 from me. And one of the easiest way of doing is to have a trusted third party and involve that third party into the transactions, right? In logical systems also we have got trusted systems, and whatever information is being exchanged between the two parties is managed by the trusted third party system, which stores the information. And later on, in case of fight between the two entities, the third party would tell whether the event has occurred or whether the event has not occurred. There are other mechanisms of achieving that as well. So the mechanisms in order to achieve the above mentioned services are encipherment, data integrity, digital signatures, authentication, exchange, traffic padding, routing control, notarization, and access control. Encipherment is the hiding or covering of the data or forming, the plain text, transforming the plain text into some non-readable, non-intelligible text, and this method provides the confidentiality. Mathematical algorithms are used in order to encrypt or decrypt the messages, as we have seen in the formulas discussed a few slides ago, that you have got a plain text and that plain text can be acted upon as per the encryption algorithm with certain keys and can be converted to the ciphertext, which is not intelligible, right? And then you have to recover that plain text from the ciphertext, and for that you need the decryption algorithm and the same key. Now here I have written recovery to the origin by some key, not the same key. Some key means that if the key used over here is the secret key, then you need to require the same key. If the key used over here is a public private key combination, then if this is private, then this has to be the public key. If this is the public key, then this has to be the private key. So some key should be there to decipher the ciphertext and get the plain text back. Then data integrity. In order to maintain the data integrity, you not only pass on the data to the receiver, but also you calculate certain mathematical values based on the data that you are passing on, which is called as checksum values. And this checksum value, which is represented by V and the plaintext P, both have to be sent to the receiver. When it is received by the receiver applies the same checksum algorithm and calculates the value. Suppose it is V dash, and then it compares that the V that it has received and the V dash that it has computed, if they are equal, that means the message that was being transmitted has not modified a bit. And this is how data integrity could be maintained. So this is one of the mechanisms for data integrity. For digital signatures, you electronically sign plain text or a document. So the plain text is now acting upon with the help of certain encryption algorithms, but now the key that is used is the sender's private key, and private key is supposed to be the private to the sender. So sender, while sending, signs with the private key. And the good thing about this cryptographic system is that when you want to decipher it to get the plain text back, you need to use the center's public key. And since it is a public key, it is widely known to everybody, and if not known, can be provided with the help of the certificates. We'll see that too later in the course. So when you calculate the sign, you send the plain text and the signed copy both to the receiver. Receiver gets them. Receiver on the signed copy, it calculates the p dash value by applying the deciphering algorithm using the sender's public key, and then it compares the message that it has got and the p dash that it has computed. If they are equal, that means it is coming from the sender as claimed, because there is only one public key for every private key. So if Alice says that I have signed it with my private key, then it should be deciphering with the Alice's public key only. And this is how it is confirmed that the Alice has sent the message. Alright. Then authentication exchange, in order to prove the identity of the entities that are involved in the communication, they ask each other questions and they tell a secret that is known only to them and nobody else. Now that is like a challenge response kind of a mechanism. We'll be talking in detail about them later on. Traffic padding is that you are adding the bogus characters or bogus information into the actual information in order to prevent intruder from performing the traffic analysis attempts onto your data. Routing control means either you have got a very secure route which has been created by you, which has got computer systems that are very secure, and you want to channelize your confidential information only through that route. That means you are having a routing control now in order to provide the confidentiality of your messages. Sometimes routing control also means that if one of the paths that leads to the destination has been compromised, then you should have alternative paths that you switch to immediately, so that the intruder has got a lesser chance of eavesdropping. Notarization is a trusted third party that controls the communication, as we have seen in the case of non-repudiation, and it actually prevents the repudiation, that nobody can now claim that whether the event has occurred or not, because trusted third party would store the information and would later on tell whether the event has taken place or not. Access control, the mechanism is that you form a list of users who can have an authorized access to a certain kind of information, and then you verify them with the help of the pins and the passwords that are provided to them. And this is how you can achieve the access control. So if I summarize my complete lecture, then we have seen the security attacks like snooping and traffic analysis, which are the passive attacks, and these are the attacks on the confidentiality. We have seen denial of service attack, which is an active attack, and this is the attack on availability. And we have seen masquerading, replay, and modification attacks, which are again active attacks, and these are the attacks on integrity. We have also seen the security services and the mechanisms. The services that you may require is authentication, access control, data confidentiality, data integrity, non-repudiation, and the mechanisms that you have are encipherment, data integrity, digital signature, authentication exchange, traffic padding, routing control, notarization, access control. In order to avail any of the services, what kind of mechanism is implemented is mapped in this chart. If you are looking for the authentication, then it requires encipherment. You need to have some cryptographic conversions in order to create the ciphertext. You need to have digital signatures because they are signed by the private key of the person. So you will be authenticated that, okay, this is the very person who has sent the message. Authentication exchange, when two entities share some challenge and response and they try to prove that I know a secret that only I am supposed to know, and this is how they authenticate to each other. So authentication exchange is one of the mechanisms to achieve the authentication service. Access control, you have got an access control mechanism that directly maps to it. Data confidentiality, encryption is required, so encipherment. Traffic padding, so that the snooping attack and traffic analysis is made a bit difficult. Routing control, that is you keep on either changing the route very frequently or you deliberately send a message from a route that you consider to be most secure. Data integrity is through encipherment, data integrity mechanism, and digital signature. And for non-repudiation, you require data integrity, digital signature, and notarization. Thank you for now. In the next lecture, we'll be discussing about the network model.